Okay, these first three I made out of this book, which I thought was wonderful because it got me started, but this book has much more complete explanations of what's really going on here, so you can really get into the details. So I'm planning to make a whole series of ones from this book. I'm up to like chapter 3 or 4, and that's what some of these last two are from. And I think Deblurring Images is still the other way. So let's talk about the deblurring one. Right here, I've got blurry and sharp images. There are online databases of them, so you can just download them from my website. I put up some subset of them, and you can import the images, and then you can see how they look like. So here's a photograph of like a ceiling with some light fixture, and here's the blurred version of that photograph. So we're going to train it to deblur photographs. We're getting a bunch of photographs where you have a blurry and a sharp version. That's the idea. So again, you split the database into training and testing. So you test size is 20% of the database. So you take 20% and set it aside, and you train it on the 80%, and then you test it on the 20%. So the images are 128 by 128 with 3 colors. And you can see that here as you use the shape. It'll tell you the train is 128, 128 by 3. So now you make an encoder, which has layers and filters, and this is the stuff which I was same in the last image one. Like I say, I'm kind of hazy on exactly what these encoders do. I think it'll be coming up in a later chapter of the better book, and I'll get more of a clue. But this encoder in Conv2D is something having to do with the early pre-processing of images to make them ready. And then the dense layers are the ones that actually do the work. So this is the encoder. The encoder has 17 million parameters. If you model it, it tells you here how many total parameters there are, 17 million, just to encode the images. And then you have which this encodes them, and then you have a decoder. You do it in these 2 steps. And the decoder is also a model with 17 million parameters. So that's the model. You go through all these stages to encode it, then all these stages to decode it, and all those are learning. So when you train the model, it is training 34 million parameters. So this is by far the biggest one we've done so far. And yet, it runs right along without any long time in here. So here's code to show the blurry, sharp, and deblurred images. Now, one of these, it takes 5 minutes to go through 5 epochs of training. The original blog I got this from trained it for something that would take more than an hour of training. So this is going to be pretty bad. If I give it only 5 epochs of training, then here's the loss. The loss is 0.6. And it's not really going down very fast, but it did go from 0.06 down to 0.059. So it didn't learn very well at all. And in fact, when you print out the results with this code, you see here's the blurry image, the sharp image, and that's the deblurred image. It's terrible. If you've only done 5 epochs of training, it isn't any good at all. It just gets a very blurry page. It's not improving the image at all, which is because there isn't enough training. So to make it better, you really have to train it for 100 epochs, which will take 70 minutes. And if you do that, it actually gets pretty good. Here's the blurry one, the sharp one, and here's the deblurred one, which is sharper than that one. And here's the same, the blurry one, the sharp one, and the deblurred one. So training it for 70 minutes is enough to get one that actually works pretty well. And I made some flags you can get using variations of the size of the data set and such. So that's interesting to see what you can accomplish with one, even though I don't thoroughly understand the code. This gives you sort of an executive understanding of what it can do and something about what the parameters are like.